Alright, so here we're going to be talking about the Pythagorean theorem. The Pythagorean theorem is used to find the missing side of a right triangle. So we're going to be given two sides, and then you need to find the third side using the Pythagorean theorem. Before we get into that, we're going to talk about the distinction between area, perimeter, and Pythagorean theorem. So again, Pythagorean theorem is used to find the missing side. Perimeter is the outside of a shape. Area is the inside of a shape. So area is the space that's occupied by a shape, the space that's actually covered by that shape. The perimeter is the border of the shape. It's how far around the outside. So the distance around the outside of this triangle does not include this 5 at all. We don't just add up all the numbers that we see. We just add up the outside sides of it. So it's 12 plus 14, which is 26, plus 6, which is 32. So the perimeter of that triangle is 32 units. To find the area of the triangle, we're going to use the equation 1/2 base times height. You don't need to memorize any formulas this year. You have everything on your formula sheet. You just have to know how to use that. So we really need to figure out what the base and the height are. We have 4 different numbers here, so it could really be any of them. Your formula sheet kind of hints at this. Every time we're looking for the base and the height of a triangle, we're looking at the right angle of it. The two sides that connect that right angle, here that's the 14 and the 5, those two that make that right angle are the base and the height. Anytime you see a right angle, the connection there, the connection of the sides there, that's the base and the height of the triangle. So 14 is our base, 5 is the height of the triangle, and now we just multiply straight across 1/2 times 14 is 7, times 5 is 35. The units for area are squared, where the units for perimeter are just the measure of that length. Here we're talking about just plain units. If we're talking about like 6 inches, 12 inches, 14 inches, the total units would be 32 inches. If we're talking about the area, then it would be inches squared, because we're talking about the square units that are actually covering that shape. So there's the Pythagorean theorem. That's a squared plus b squared equals c squared. A, b, and c are the 3 sides of the triangle. C is always the longest side. We'll talk more about that in a second. Before we do that, I just want to show you when we use the area formula versus when we use Pythagorean theorem. So the equation for area is 1/2 base times height. Pythagorean theorem is a squared plus b squared equals c squared. All right, if we need to find area, then we're going to be given the base and the height. If we're looking for a missing side of a triangle, we have to have 2 of the sides. We already need to know 2 sides. We're looking for the space that's covered by that shape, or the area. For Pythagorean theorem, we're looking for the third side, the third missing side. This is just breaking down all the different parts of a right triangle. The 2 short sides, the 2 sides that connect the right angle, really our base and height of a right triangle, are actually called legs when we're talking about a right triangle. And that's going to be the A and the B in this Pythagorean theorem. The side that's across from the right angle, the one that's across or opposite the right angle, is called the hypotenuse. And that's going to be C in our formula. The hypotenuse is always across from the right angle. The legs always form the right angle. So this is called a right angle. Never assume it's a right angle. You need to see that box. That's what's telling us that it's a 90-degree angle. All right, so we're going to be given 2 sides, and we're going to find the third side using this formula. So our first step is always just label the legs and the hypotenuse of the right triangle. Sometimes they're going to flip it around and it's not going to be so clear. You always want to look for the one that's right across, directly across from the right angle. That's the longest side, and it's the hypotenuse. Then we're going to substitute numbers in for the missing values, for the 2 variables that we can replace, and then we'll solve for the missing side. Make sure your answer always makes sense. Again, the hypotenuse, the one that's across from the right angle, is always longer than the other two. So you can always check it that way. If you get a side that's shorter than the two legs, you know you did it wrong because the hypotenuse has to be longer. And the Pythagorean theorem only works for right triangles. Alright, so our first step is just labeling these two. We have our two legs that connect this right angle. We're going to label those as A, B, and we are missing C. That's the one that's across from the right angle. Now we're going to substitute our values in. We have 5 as A, 12 as B, and C we don't know yet, so we're going to keep that as C. I'm pretty much always going to do it in order from least to greatest, just because that makes the most sense, because this number, the C, has to be the biggest, so it just kind of makes sense to go from smallest to biggest, but you could put the 12 and the 5 in opposite orders. Now we're going to solve this exactly like the equations that we learned in our last unit. Before we do anything, really we just have to simplify the left side. You're going to follow order of operations. We're going to square 5 to get 25. And then we're going to add that to 12 squared. 12 squared is 144. That equals C squared. We're going to add 25 and 144, that's 169. And that equals C squared. That doesn't equal just C by itself. We need to figure out exactly what C is. So that's really saying that some number times itself gives us 169. The way we solve any equation is using the opposite operation. So the opposite of squaring something is doing the square root of that number. So we're going to use the opposite operation of squaring something, that's square rooting something. Those cancel out, and we do the exact same thing on the other side. If you do it on one side, you have to do it on the other. This just cancels out. We're just left with C on that side. And we do the square root of 169, and that's 13. We always want to check this. Is that longer than the other two sides? Yeah, 13 is bigger than 5 and 12, so we did that correctly. You can also just plug it back into the equation and make sure it makes sense. 25 plus 144 should equal 13 squared. On the next one, we actually have a typo there, but that's going to help us check to make sure that we're actually doing this right. So we're looking at the right angle to find our A and B. Those two sides that connect that, form that right angle, are the A and B. We actually don't know one of those. I'm going to say that this is our A, which we don't know yet. So we're missing side A. We don't know the shortest side. We know that 10, I'm going to change this 5 to a 10. That's our B. And 25 is across from the right angle. So this is our C. Now we're going to substitute those numbers in where they're supposed to go. We don't know A yet. We know B is 10. And we know C is 25. Now we're going to solve this again. We're just solving the equation for A. We're trying to figure out what A is once it's by itself. Before we do anything, we have to square these two numbers just to figure out what those are. We have A squared plus 10 squared is 100 equals 625. That's 25 squared. Now we're trying to undo the operations that are happening to A. We're trying to solve that equation. So we need to work order of operations backwards. We're going to cancel out this plus 100 first by subtracting 100. Cancels out with plus 100, and A squared is 525. So this is almost done. We have to cancel out this squared. By doing the opposite of that, we have to square root both sides. That's just going to cancel, and we're going to do the square root of 525. That tells us that A is about 22.9 centimeters. Again, we want to check to make sure that this makes sense. The hypotenuse, the one across from the right angle, not the one that we found, the one that's across from the right angle, that's 25, that's bigger than 10, and it's bigger than this new side that we found, the 22.9. You're going to do these four on your own. Do it exactly how we did it on the front. If you need to go back and watch the video, go back. I will draw a picture for number 4. We can also use this to test to see if it is a right triangle. Actually, this is really just checking your work on the previous examples. We can test to see if it's a right triangle just by plugging it in and actually making sure that we're going to substitute values in for each variable. We're going to simplify each side of the equation. And if If the numbers are equal, then it's a right triangle. If they're not equal, then it's not a right triangle. If the Pythagorean theorem doesn't work for a triangle, then it's not a right triangle. Alright, so we have our three sides, 16, 30, and 34. Again, I'm just going to write that in order from least to greatest. That's my A, B, and C. And I just want to see if the left side actually equals the right side. So 16 squared is 256. 30 squared is 900. And 34 squared is 1,156. We just want to make sure that that's equal. So 256 plus 900 equals this equals 1,156. So that means this is a right triangle. We're going to do the same thing on the next one. This one we've got to be careful. The biggest side has to be C. So we're going to reorder these three sides. 42 is our C. 21 I'm going to put as our shortest side as A. And 29 is B. So we're going to do 21 squared plus 29 squared. And hopefully that'll equal 42. If not, then it's not a right triangle. 21 squared is 441. 29 squared is 841. We add those together, and we get 1,282. We want to see if this is the exact same number. 42 squared is 1,764. Was not the same. Not a right triangle. Alright, the toughest part of this is when they give you a picture that's not really a clear right triangle, and maybe you have to form the right triangle for yourself. That's definitely the toughest part of this. On this first example with the diagrams, we have a 10-foot ladder. The ladder itself is 10 feet, and it's placed 5 feet away from the building. How high up on the ladder, how high up on the building does the ladder reach? So we want to know how high that is. We want to know that missing side given the longest side, the one that's across from the right angle, and the shortest side. So we have A squared plus B squared equals C squared. We have our shortest side, that's 5. We're missing the middle side, we don't know B yet. And we know C is 10. That's the longest side. So we're going to simplify each side first. We're just going to do 5 squared, that's 25, plus B squared, and that equals 100. That's 10 squared. Now we're going to solve for B squared first. We're going to get rid of that positive 25 by subtracting 25. That gives us that B squared is 75. B squared is 75. So the number times itself that gives us 75 is B. We're going to do the square root to find that. The square root of 75 is 8.66, and here we're talking about meters. So that's how high up on building the ladder actually touches. This is about 8.5 feet. And that should make sense. The 8.66 meters should be less than the 10 meters. First off, it's not the hypotenuse, so it should be shorter. And a 10-meter ladder standing slightly slanted up against a building is not going to get up to 10 meters. It should get a little bit less than 10 meters. We want to know how far it is to throw from home plate to second base. Home plate is this. Second base is here. So we want to know how far that distance is. It's a little bit tricky because they actually don't give us a right angle or a right triangle. They give us a square there, and we need to form that right triangle for ourselves. This is the right triangle that we're dealing with. We have that distance, straight up and down, and the two base paths that form our right angle. We don't know this side yet. We don't know the C, but we know the two short sides that form the right angle. They're both 90. So our A and B are 90 each. And we don't know C yet, so we're going to leave that as a variable. Now we're going to square 90 and 90. It's 8,100. 8,100 plus 8,100 is 16,200. That equals C squared. We have one last step. We're going to take the square root of that number. That gives us that C is 127 feet and a little bit extra, about 127.3 feet. Straight from home to second base. Which again makes sense because it's the hypotenuse of the triangle and it should be longer than 90.